Hey, what is up, everybody? Thank you very much for coming back to part three of this long journey that we've had on writing the code to find the different segments that we're going to segment the array. So let's get down to it. Last time, I do recommend that you check out the video before this and obviously the video before that, part two and part one, so that you know what's actually going on. So let's take a look at that. So here we have our use case, which is the list of shots that we have. And as you remember last time, and I'm not going to repeat it because, again, we already did that in part two, there are duplicates within this array, and they're labeled by the appropriate letter. And each letter represents a shot I guess, a movie. And we want to segment it such in a way that the first shot doesn't contain, well, the second, all the shots will not contain any duplicates of other shots. So if we take a look at this array here, and last time we were able to find where the max duplicate occurs, right? So if we take a look, we know that shot A, the max occurrence of the duplicate is at element 8, right? And then shot B, the max occurrence of duplicate is 5. Okay, so, and we stored this in a dictionary. So what you're looking at the table below is a visual representation of what our dictionary looks like, where we have the shots as your keys and the max occurrence of duplicate as the value, right? And we have this set up in our code already so that we can take a look at in a little bit. And now I'm going to go through the second part of the algorithm because we already went through the first part. So we did one whole iteration and we found this dictionary first, right? So we can say that that's O of n. But now we have to go through again and check where we segment the array. Okay, we have to check it because we first need where the duplicates are, and then after that, we need to check where, comparing to our dictionary, where we segment the array. So it looks like, for example, if you look at A, right, the farthest duplicate is going to be the eighth element, correct? And as we go through, let's say we are in the 0th element in our shards array, okay? When we get to B, we compare and see if that specific max occurrence is going to be greater than where our original A was, right? And you see that the max occurrence of A is 8, which is greater than 5, which means that our goal right now, right, at this point in time in our loop, is to reach up to 8. And if there's anything greater than 8, then that's going to be our new segment, okay? And as long as we're constantly comparing when we're going through our shots array, okay, so we can call this our shots and these are our duplicates, we can see as to what segment we can throw out. So for example, right, if we have A, we know that A is greater than 5, right? Then it's going to go to I'm sorry, B, which is greater than 5, and then even C, which is greater than 7. When we get to D, okay, because 14 is greater than 8, then I think at this point we want to segment our array, which means that the first segment is going to be a count of 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you remember back in the example, that was the first value that we should have returned, right? So it was, I believe it's 9, then 7, and then I think it's 7 again. But we'll take a look as we go through and debug. Okay, so I hope you understand where we're getting at here. So obviously the outer loop is we're going to have to iterate through this array again. And when we iterate through the array, we're going to constantly compare to our duplicates array. And what are we comparing? We're comparing the max occurrence, right, to where we're currently at. Okay, and then if it gets to a point where the right index is greater than, okay, we want to segment it at that point. So let's take a look at how we would kind of represent that in code, but I hope you kind of have an idea of how this is going to work. Okay, so let's take a look. All right, so this is the code that we're looking at where we were iterating and finding the duplicates. If you remember the last time we found this dictionary here on the bottom. Now, the next step is we're going to iterate through the shots array again. So you definitely have to go through it again. So we'll do an int I is equal to 0, I is less than shots.count, and then I plus plus, right? So this outer loop is going to allow us to iterate one by one right here. And we want to keep the index as to where we're currently at and compare with the index of our duplication. So on the first iteration, we are going to compare the index of A with the index of A in our max occurrence duplicate dictionary. And then we're going to find which one is the max. We need another variable for that because we want to keep track of that. I think we can say that it's the right index. Initially, it's not, it's just the initial index, but as we're looking forward, you want to take the right index or the max, okay, so that you can segment your array. So I think it'll be more clear if we start actually coding it. So let us say that we declare a variable called right. Okay, so right will represent our current index of where we're at, okay, initially. So we're just going to initialize this to 0. Okay, and then what we want to do is we want to make the right, meaning when you say right, the segment that we're going to split. Okay, so right is going to be the max between right and where I'm currently at in my duplicate dictionary. Okay, so let me write this out real quick and then I can explain to you what's happening here. So we initialize right equal to 0. So what's right equal to 0? That's our initial index here, right? That's we make it at 0. But I said that we have to compare because we want to know where we should segment, right? So far we could only look at A, and if we compare 0 to the duplicate value of where the max occurrence occurs for A, which one is greater? The greater one is 8, right? So that now becomes our right, which means that the right is going to be where we are going, initially we're going to segment, right? If we find something greater than that, then that will move, this right will move up. Okay, but for now, because we ran into this case here, initially we compare 0 to this max occurrence, which is 8. This is now our new segment. So this is what we're aiming for to segment at. Okay, And that's why we compare the right, which is where we're currently at, right? And what's our dupes? Dupes, again, is where we're currently, our duplicate dictionary that we built, right? And then shots of I, because shots contains, we go back to our little shots of I right now would be A, right? And that's exactly what we want to get. What is the shots of IA? We're just fetching the key here to get this magic 8. Okay? So who's the max? Well, the max in this case is going to be, you're comparing index 0. So if I write a comment here, index, so we're actually looking at A, right? And compare index 0 to index 8. So who's greater? Well, the greater one is going to be index 8, okay? So index 8 is going to be our segment point, okay? Our segment point. Okay, so that's good so far. So we have to constantly do this, okay? Now, how do I know when to throw in the segment value? Okay, so we're gonna figure that out right now. So if we compare, and let's say we arrive, right? So we're gonna arrive, because eventually we're gonna get to 8, right? Because it's gonna iterate through, right? Because of this outer loop, we're gonna iterate through up to 8. So what do we do when we get to 8? Okay, meaning that what happens when right, is equal to I? What do we do when that happens? Well, when that happens, we want to add to our scenes. And what we can do is we can say scenes dot add, okay, 1 plus right, okay, because remember when we compared 0 to 8, who won? 8, right? Because that was our farthest index. But the scenes have to be in non-zero counting, right? So meaning that if our segmented index is 8, then really the first scene should be 9, right? It's made up of 9 shots. Okay? It's made up of 9 shots. Now, that's all in good because we're starting our count at 0. But what happens when we get to this index here? If we compare, okay, if we compare the index again, so in this particular case, once it gets to this, right, our max index is going to be 14 right now, right? Because between 9 and 14, who wins? 14. So right now we're looking at segmenting over here. But eventually we run into E, right? And when we run into E, our max segment is going to be 15 because 15 is greater than 14, right? And then we do F, that's still less. Then G is still less. And then when we get to, we're going to eventually get to E, and that's when we want to segment again. Okay, so I should actually put an arrow here, right? What's our count? Our count is 1, 2, 3, 4, 5, 6, 7. Okay, this will not work because right is going to be 15, right? 1 plus 15 is 16. So what we need to do is you got to keep track of the left hand side. Okay, so we're going to declare another variable here, and we're going to call it left. And the reason we use left is for this specific use case where if you're going to have another segment farther away from the array, right? Because you're going to have more than one. You want to subtract of where you currently were. And to do that, so we're going to see right minus left, right? But if we rewind to the first time we got to 8, right? What's going to be our left? I'm sorry, our left. Our left is going to be right plus 1. Right plus 1 because this is going to give you 9, okay, for the left. And when we get to 15, we want to know that we're going to subtract 15 minus 9, okay, plus 1, right? Because you've already gone through the first segment. Okay, so the purpose of this left is just to keep track of what currently happened after we went through this segment here, up to this segment here, right? Because then after, so now we have, the next segment's going to be, let's see, 1, 2, 3, 4, 5, 6, 7. It's going to be 7, okay? But how do we get to that 7? Well, we get to 1 plus is 15 minus, and then the 9 that we had before, right? So 15 minus 9 is going 6 plus 1 is 7. Okay, so and that's on the second segment. Then when we get to the third segment, right? So we stopped here. The third segment is going to be, let's see, H is 19, L is 21, and then J is 23. So J is our highest. So 23 is going to be the next segment here, right? That's going to come over here. Okay, that's what we're looking at as to where we're going to segment again. So eventually we're going to get to the point where we reach 23, right? And on the next case, what happens? Well, on this segment you have 1 plus, right? Right is 23, right? Because of J, that's the max. Minus the left. What was the previous left? Well, the previous left was 15 plus 1, right? Because it was this over here plus 1, right? So, which is going to be 16. And if we do the math, you're going to get, that's going to give you 8, right? This is going to give you 7. And obviously the first one gave you 9. So the reason why we're doing this left and we're subtracting is because we are counting from 0 in terms of the number of shots, right? The number of shots of the last point where we left off. Okay. And eventually that's it. You're done. I mean, it seems like a pretty simple coding algorithm, except that obviously there's a lot more to it. Okay. Okay, so this again, you were iterating through the array twice. First time is to find the duplicate occurrences, and the second time is to actually compute the scene. Okay, the number of shots in a scene. Okay, and that eventually will get you to that point. Okay, now extra credit. I will give you extra credit if you can print out the scenes array. Okay, the scenes array. It should be easy. Okay, you should just so you shouldn't print it out here. You just want to return that back. But after each call, you probably want to just do another loop and just return it back. And usually, if you're using this in a tech interview, they'll have the printout for you already. Okay. And that's it. I mean, that's pretty much it in terms of the code. So I hope that this has enlightened you and made you think. There's a lot of stuff going on here in terms of iterating through an array and just the most efficient way to compute the number of shots in a scene. This is one of the most efficient ways that I found. If you find another better way where you need to iterate through the array just once, I'd love to hear it, and I'd love to see an explanation on that. Okay, but this guarantees you that you're gonna at maximum gonna go through the array only twice. Okay, only twice, and you're always going forward, right? You're never gonna go back or looking back. You're always going forward. So you can say that this is O to the n or O to the 2n in terms of efficiency. Okay, so thank you for looking at the code and the video, the 3-part video. So this pretty much seals it. I hope that you got a lot out of this, and I'll see you on the next problem. So thank you.